The exponential increase in orbital launches over the last 10 years has driven down the cost of sending payloads to space. Significantly more companies are now developing unique space missions, but lack the time, expertise, or resources to develop their own propulsion systems. The Society for Advanced Rocket Propulsion's Orbital Transfer Vehicle propulsion system will provide final mile delivery services to bring rideshare customers to their required orbit, offering greater flexibility of operations for a fraction of the price.
Over the last 5 months, the SARP Capstone Team has been perfecting the design of an in-space propulsion system that could be integrated onto a 300-kilogram spacecraft. The team utilized industry-standard design and analysis tools to develop the rocket engine, fluid feed system, propellant tanks, and supporting structure to ensure that the final spacecraft could safely launch on a SpaceX Falcon 9 rideshare mission and accelerate a 100-kilogram payload by over 800 meters per second within 24 hours of launch. Of course, the only way to be sure a design works is to put it into action. SARP Capstone members adapted a version of the engine for testing down here on Earth. Machining such a compact rocket engine required complex manufacturing techniques from CNC machining to welding, brazing, heat treatments, and even good old-fashioned elbow grease. Alongside the engine, the team designed and manufactured a custom test stand, data acquisition system, and fluid feed system to conduct test fires safely and effectively here on campus. Throughout the last quarter, detailed tests have been conducted to check that every component works in harmony for an engine hot fire. This includes both injector and fluid system cold flow tests with inert fluids. Additionally, igniter spark tests were completed so that we have more than just an expensive sprinkler system when the moment counts. Of course, the SARP Capstone team believes in having fun along the way, so here's Connor to introduce our test stand fluid system.
Hi, my name is Connor. I'm an ME student with SARP Capstone. I'm going to run through our fluid system. Here's the GOX panel. First of all, you'll notice that we have an inlet and an outlet. The outlet is where we go out to our engine. In order to manage our pressures, we also have a regulator. The regulator is right here. We'll go anywhere from 0 to 90 psi. In order to operate our system, we also need 3 valves. The first valve here is our ox bottle valve. That's how we make sure oxygen gets into the panel. We also have an oxygen purge valve. We purge the system with helium to make sure GOX doesn't build up in the system. And at the end, we have an ox vent valve. That way we can ventilate our system and remove any GOX that we have.
As we complete our final preparations for a hot fire test, we on the SARP Capstone team would like to thank the following people and sponsors for their help in making this all possible.